Hi, all. My name is Nancy Briggs. Welcome to our November monthly seminar. Before we start, I would like to acknowledge the Bedical people that are the traditional custodians of this land. I would also like to pay my respects to the elders, both past and present, and extend that respect to other Aboriginal and Torres Strait Islanders who are present here today. I'm really happy to introduce our speaker today. Luz Palacios-Derflingher is a new member of our team. She started here in September, and we hired her to help us out with the new Randwick Health Innovation Precinct. And so her entire position really is meant to support all the researchers and students. Somebody's saying that they're having a hard time hearing. Can you guys hear me? Okay. So, April, I think it might be you. Other people seem to be able to hear. Okay. So Luz, we hired her specifically to help the researchers there, and she joined us in September, and she comes to us from Canada. She was working in at the University of Calgary for a long time and moved here about a year and a half ago, and has been working at various places in Wollongong. I'm so pleased that she came to work with us. She comes with great experience in biostatistics and lots of experience doing consulting. So she is a great person to come speak to if you are an RHIP researcher, and she can help you out with planning out your research and giving you good ideas for good statistical analysis of your data. So Luz, go ahead and share your screen, and I'm very happy to have you speaking with us today.
Oh, thank you, Nancy. And I'm going to start. Can people hear me?
Yes, we can hear you.
Yep. Okay. So now you can see my screen, right?
Yes.
Okay, perfect. So my talk is, well, the title is Informal Statistical Practice and Some Diversions. So I'm going to be talking about experiences that I've had in terms of the consulting process. Feel free to ask questions in chat. I might not be able to see them, but some of the members of my team might be able to tell me if I need to answer some things right away, or if not, I'll answer at the end of the talk. So I will start with, let's see if this moves. Okay, yeah. So, well, the objectives of this talk is I would like to convince you of the importance of having aims, research questions, and statistical planning connected, involving a statistician or a biostatistician from the beginning of research to better understand the research question and what needs to be done. And also we'll point out that statistical research does not involve just answering a quick question most of the time, that correct use of statistical analysis depends on understanding the question and pitfalls that I've encountered throughout my career. So I have two examples. I'm going to present two examples. They're not exactly the same as the ones that I've dealt with. I changed either population under study or what they're measuring, but they're very close to what I've experienced. So, for example, this one, the first one, I get an email asking for a calculation of the sample size. And the research question is, what is the effect of a treatment on injured players? No treatment versus treatment. Now, my examples, some of them are going to be in injury because I work in injury prevention for a while. So that's why I'm talking about that. And then, well, is this information enough to calculate a sample size? So I don't think it is. Well, not that I don't think it is not enough to calculate a sample size. So then we have iterations going back and forth. That's why I label them as iteration number 1. Sorry, I did something here. Sorry, iteration 1 and then 1.1 and then 1.2, because it's basically the researcher asking me questions, 1.1, and then I answer them back with 1.2. So I have to ask them, what is the population under study? The subjects and outcomes independence? What type of injury, restrictions on when the injury happened? What type of design? What is the treatment? What the length of this one is? And still keep on going. how and will the outcome be measured, the type of variable, et cetera, et cetera. So all these questions I need to know in order to calculate a proper sample size. And also they already have ethics for that. So now we go back to the iteration 2.1, answering those questions. So we're going to be talking about hockey players, males age 15 to 18, and the subjects are independent and outcomes will be measured before and after. Then it's head injury and restrictions when injury happened previous week before recruitment. Still, as answering those questions, so taking medication 2 times a day for 1 week, it's an RCT, and it's going to be measured by questionnaire, and some information about this measurement that yields a value between 0 and 78. Now, still, what the clinical important difference affected is, and what they mentioned is the difference between treatment and control of 15. So that's what they mentioned, and level of significance and power of the test, 0.05 and 0.9. Now, still, after this, there come more questions, because then it's still questions after questions. So how long will the study last? How many participants could be recruited? And this is, for example, sample size based on this feasibility. This is one of the things that I encounter a lot working in health, that sometimes we're asked to calculate a sample size. You do all with the power and everything, but at the end, you're told, well, I can recruit maximum of this much. So that's why it's always, I think, important to ask, how many do you have access to? Do you have restrictions and costs? Also, what is the participation rate and the attrition rate? Because if you're going to measure it through a time, then you might be losing some participants. And how will they be recruited? Plans for randomization, compliance, will it be measured, and how, and so on. Now, still continuing with questions, how and what will the questionnaire be collected? And also, if it's before and after, if the techniques are going to be different, will this impact the answers? Because it's not the same. They come at baseline, you might see them in person, but then at the end, how will you measure the questionnaire? How do you make the questionnaire happen? And has the questionnaire been validated to measure pain in this population? This is a very important one, because sometimes researchers use methods that have been done and things that have been used in other populations, but not in the population that they want to measure things on. Now, can other factors affect the outcome? Would other therapies be checked, taken into account? And also confidentiality of the participants. And as you can see, questions again happen again, come and go. And after several iterations, let's say that we decide to do a simple test for analysis, which is a 2-sample t-test. In this case, would be comparing effects of treatments of before minus after change. So in this case, we'll be calculating pain score before minus pain score after. But then for the sample size calculation, we would need the difference of this new variable before minus after for the treatment, and then the difference of this with the control, and then the standard deviation of this one. So you can see they had given me an effect size, but that effect size doesn't apply to this example because we need that difference of the differences. So that means that the iterations still continue, because now they have to check what the difference is that they want and the standard deviation of that difference, et cetera, et cetera. So that's one of the things that I wanted to stress, that is not just calculate a sample size and that's it. It's easy. It's more of a back and forth of the process. Questions so far? I don't know. Even that, I'm going to move to example number 2, which is I get an email saying, can we have a 5-minute meeting? I get a lot of those emails saying, I want a 5-minute meeting. Can we please, talk about? I want advice on statistical method use and an interpretation. So this means that they already did the analysis and they just want advice on if it was correct or not. The research question is, what is the association between injury and exercise? And they mentioned that they have a deadline that they have to submit an abstract in 1 week for a conference. So, well, this information enough to provide advice. Again, it's not enough information. And also the deadline of 1 week, that's a little tricky. So that's again, the iteration 1.1. Then we go with questions that I have to ask. What's a population under study? What type of design? Prospective or retrospective? Was it cross-sectional, longitudinal? What type of exercise? How was it measured? For how long? Et cetera, right? The type of injury, how was it measured? And since they already did the study, what hypotheses they had and what methods they used and what results and interpretation they had. Okay, come back to me. They mentioned volleyball players, high school students, 15 to 18 males and females, observational study, data collected prospectively, and it was cross-sectional. Then type of exercise, what they measured was jump counts. So they had this vert accelerometer, which measured when they jumped, well, how many times they jumped throughout a game. So then for how long? For 1 week. And the type of injury is if they had patellar tendinopathy and how it was measured. Well, it's the beginning of the 1 week with a questionnaire. Now, hypothesis. It was hypothesized that higher workload in volleyball players measured by this jump count is associated with higher PT, clinical diagnosed PT. Method, what method they used, and they used a multiple linear regression to check this association, adjusting for other variables, cluster by team, and they used the mixed effects model. In results of the interpretation, they showed me that they had a beta coefficient from the regression analysis with PT being the main exposure. The beta coefficient was 44 with this confidence interval. And the interpretation is a result suggests that higher workload may be associated with the development of PT. This study provides preliminary insight on the effects of workload on players' health. Now, in this case, I'm going to mention more questions and red flags about this thing, because it was, first they said that it was a cross-sectional, but jump count was measured during 1 week, so it was not necessarily cross-sectional. More questions is which high schools were sampled, how they're chosen, is this the sample representative? Is the week when it was measured usual representative? And that means that, because, well, they play, was it playoffs, was it a normal season, et cetera, just to see if that has an influence. Now, is VERT a reliable measure? Has a questionnaire that measures pain been validated in this population? And the analysis, so outcome is count. So maybe a Poisson regression is better than what they did. Do they have to cluster by high school, not only by team? And well, the question, do they have time to repeat the analysis in mainly the 1 week that they have to submit the abstract? And does the analyst have the background and skills to do it? So yeah, abstract doing 1 week, it's a little tight. But one of the things that I wanted to mention is mainly the interpretation that it had to do with temporality. The interpretation was a result suggests that higher workload may be associated with the development of PT. Now, for this interpretation to make sense, what was measured first and what was measured second? First is workload, so that means the jump counts, and second, PT. In this study, what was measured first and what was measured second, it was the other way around. So believe it or not, I had to modify this example, but this was an example that I had, which the interpretation was done differently. The conclusions were not correct. So are the research question, methods, analysis, and results connected? No, because the research question, they had one research question, they analyzed it, maybe not with the ideal analysis, but the interpretation is completely different to what they were doing. So I guess after this, well, some conclusions from this is that I have not presented all the questions and iterations in these examples. It was some of them. When we're doing consulting, some questions are general, but some questions depend on the project. It says it's not only one iteration, it's a back and forth process. It's not only just calculated sample size and then here it is and that's it, right? It's more of how things were measured, how Yeah, so if they have validity, if they're using a questionnaire, the type of population, et cetera, et cetera. So that's why it is better if we statisticians, biostatisticians, have much information as possible to avoid some iterations. So when I start my consulting, I always try to ask what's the research questions, what the background, et cetera, et cetera. So if possible and available, it will be good to have the proposal or answer those questions, again, if they're available in the first iteration. Sometimes I've got some people come to me and say, you know, I don't know much, like exactly what I want to do. I have this idea. So it's a process of back and forth, but it's not just a one question or one email and then answering back another email. So I have already presented that having aims, research questions, and statistical planning should be connected. That involving a statistician is better if you involve from the beginning, that it does not involve just answering a quick question most of the time, because the 5-minute question that they had, of course, it turned out to be way bigger than a 5-minute thing, and it was going back and forth and back and forth. And the correct statistical analysis depends on understanding and the correct setup of the research question and the study design. Now, some of the pitfalls that I've encountered, and for these pitfalls, this is experience that I've had, and I'm going to be using some quotes from some papers, and some of them is people that are big in statistics. And so I separated this in some of background, methods, analysis, and so on. So background, what I've seen is when they talk in the background, they talk about past studies and then sort of criticize those other papers in the subject, but then they don't, for example, adjusting for covariates, but then in the project that they want to do, they don't solve this issue. So if they're criticizing what hasn't been done, but you're not gonna be doing it, then you're criticizing your own project. And also some of the things that not mentioning validation of the instrument survey that they will be using in the project. So that has to be checked so that the results are valid. Now, methods. This one, I'm going to be mentioning some of them individually, but I'm going to be touching on doing something because it has been done in the past, even if the method or the summary is not correct. Temporality, categorization of a continuous variable based on percentiles of the sample. Wanting to test many things, not specifying in the aims. Sample size. So doing something because it has been done in the past, even in the methods, is not correct. So this was a publication that had to do with patellar tendinopathy. That was this was in basketball players. And we had graphs. They measured this PT each week. And they wanted to summarize this with means and standard deviations. Just say, okay, calculate the mean of each of the graphs and standard deviations. So, which in this case, we have, for example, in this one in the middle, in the top one, we have a lot of variability. So means and standard deviations, summarizing with that, you lose a lot of information because you start very, very low, you go up. So then you have a lot of variability. So at the end, what I told them is just describe the graph. Just tell them that it's going up, down, but don't try to summarize it. But what they wanted to do was the means and standard deviations because that's what other papers had been done in the past. And then this one, what I'm going to be mentioning is paper. Well, here, this is a quote for Blanche. This is a famous statistician. And this paper is from 2004. In this case, this is papers where the statistical methods are copies from a previous paper in the field, which was in turn copying from a previous paper, et cetera, et cetera. Now, here I'm stressing the year 2004 because the previous example that I showed you was, we dealt with that after 2010, maybe around, after 2015. So it was mentioned a while ago, but it's still happening. And then he has this quote saying, doctors who don't realize that statistics is an advancing science and the best methods of 20 years ago are not always the best methods of today. And this also happens with people that are not up to date. Sometimes it includes us statisticians, but people should be open to new methods that are out there. Now, we're going to be talking about temporality. Well, temporality is the example basically that I showed in one of my consulting experiences. Is our results suggest that higher workload may be associated with development of PT, and well, PT was measured first and were looked after. So temporality sometimes is not used correctly. And well, now I'm going to be going to the third one, categorization of a continuous variables based on percentiles of the sample. Now, if we use percentiles, this is used a lot, for example, median. So different cut points will be used in different studies. And that means that it won't be easy to compare from previous studies because each time we're going to be using a different median when it's partitioned. And there's this paper that has this example where we have people A, B, C, and D with these values. Let's say the A has this value, B and C have similar values, and D has a similar to A. Now, if we divide in the median, we're dividing and dichotomizing in, let's say, low and high. So we're gonna end up having A and B together and C and D together. Now, difference between individuals B and C before the dichotomizing was small. But now, after the separation, after the dichotomizing, we're saying that B and C are different. Now, difference between A and B before was large. We can see these points over here. But now we're saying that they're the same. So that's a part of dichotomizing. And well, there's this paper and other papers that have several reasons for not doing it, that you lose a lot of information when you do it. The power is very different. The significant results change. But at least this is something that graphically shows that it's not ideal to categorize continuous variables, because then you end up putting together some individuals that originally were very, very different. So then now, well, a quote from, again, Bland, 2004, some researchers might be tempted to split the sample, not at arbitrary cut points, but they will be looking for cutoffs to minimize the p-value and get something that is significant, which, of course, ethically, that's not correct either. But also that's also one of the bad things that can happen when we're categorizing continuous variables. Now we continue to point number 4, wanting to test many things, not specifying in the aims, and then having many things analysis and results. So as an example, I have aim of the study. We want to evaluate if there's a difference in weight between group A and group B. Analysis, we perform a 2-sample t-test. Again, an easy one. I'm just choosing a simple example to compare the mean weights between these groups. And the results conclusions is with a 5% significant level, we have evidence to conclude that the mean weight for group A is higher than a group B, and then they present the point estimate of this, right? But also we also have evidence to conclude there's association between weight and sex. So what's weird with this is that there was no mention in aims and that there were going to be an association with sex. There is no mention of what test was performed, why the p-value, how did they check that? So they're concluding things that we have no idea how they were done, and also they were not part of the aims. Plus, another thing is that they mentioned the difference of 3 in weight with this confidence interval. So is that clinically important really or not? And that's another issue that happens out there. Then, sorry. In this case, well, this is a quote, but this is a quote that should be followed. So all statistical methods applied should be described clearly, correctly, and with enough detail to enable someone to know how things were done. So I will always, try to encourage to have enumerating the aims and then enumerating what methods they're going to be using, and also enumerating the results and the conclusions so that we know what was used and that there's no confusion out there. Then something that is connected to this point but then not necessarily, it's not using the method stated in the method section of this paper. That's another thing that it's out there a lot. And well, sometimes that happens because papers don't have iterations. Sometimes they do one analysis and they change, but we have to be careful that this is corrected later. Now, sample size. Sample size, one of the pitfalls is, well, for sample size calculation in a grant, in a paper, we need to have all the information that was needed to calculate the sample size so that we can replicate it. And that's one of the things that I've seen grants, or I've seen ethics approval or papers that don't have this information, but we need, this has to be in the grants and in the papers. Now, data and analysis. So the pitfalls that I've seen in data analysis is that people underestimate some things, and well, the researchers, or overestimate some things. So for example, cleaning of data. This is always underestimated, because even if, well, more so nowadays that we collect things online, people think that everything is clean, but not necessarily, right? So yes, try to have clean data from the beginning, but that doesn't happen all the time. So always allow time, some time for cleaning the data. Time it takes to do the analysis, researchers underestimate this. Sadly, nowadays, it's okay. I know that software is available out there, that it's easy to click on it, but people have to remember that the methods need assumptions, that we need to check many things in order to analyze things. So yeah, some researchers underestimate this. It's not just a matter of finishing in 2 days and we're going to have, maybe sometimes people are lucky and in 2 days results are done and you have it, but most of the time my experience is it takes a long time to work on these things. Now, researchers and analysts background to perform analysis, sometimes people overestimate this. So we always have to check what background, and mainly my experience has been dealing with students, when students have not taken all the subjects or the courses, and they want to do like all this more complicated techniques. So just, well, we have to take into account that also. Now, another thing, data analysis, wrong test, and this is mentioned in the paper from 2007, again, long time ago. And this was experience that I had, one of my experience, that it was a two-sample t-test versus per t-test, and they wanted to compare if a treatment in diabetic patients was successful by lowering the blood sugar. And they took measurements baseline and after treatment. And what they had done, of course, what I told them is that a per t-test was needed, and then they did a two-sample t-test. Now, this is a different thing, because when they did a two-sample t-test, the results were significant. So that's what they wanted to show, but that's a different story. That has to do with ethics and other stuff. And what else? Now, results and conclusions. So descriptive statistics. So I'm going to be talking about several points here also. Descriptive statistics, making conclusions that do not go with the research question, and saying that a difference was found when a statistical significance was found, but no clinical significance, and conclude only significant results, and concluding no difference when results are not statistically significant, and when you generalize, and describing based on bad graphs. So I'm going to go over these points. So descriptive statistics, using wrong summary descriptive statistics. I've seen this still happening. For example, we have categorical data such Likert scale with disagree, neutral, and agree, and they still calculate means on this. And well, being categorical data, this shouldn't be done. Or for example, using mean versus median. I've seen a lot still using median. No, here, well, median should be done. And I've seen people using mean of length of stay in hospital, when length stay of hospital is skewed to the right. So they should be using median. Now here, this paper in 2007 still says it's using adequate statistical measures of central tendency and dispersion. So again, pointing out the year 2007, and I've still seen this, well, recently, that people don't use the correct descriptive statistics. Now, something that is still done a lot is the mean, and then using the plus minus, and then a number over here. And usually this YY means standard deviation, but here we have some code that says that this symbol, it's rather misleading, because we're not saying, if people refer to the standard deviation, but what this means is that they lie between the mean minus standard deviation and mean plus standard deviation, which is, that doesn't happen. So standard deviation should preferably be reported in parentheses, so mean and then parentheses standard deviation. Also, because sometimes use this numbers, the YY, as the standard error. So it's confusing. Now, making conclusions that do not go with the research question methodology, same example that I had before, that workload was associated with development of PT, and well, this is not correct. And one of the quotes is drawn conclusions not supported by the study data. Now, saying this, the difference was found when the statistical significance was found, but not clinical significance. And for example, it had blood pressure. If you're told that a medicine can lower your BP and the results are significant, but the before minus after is 3 with the confidence interval of 1 to 5. So yeah, there is statistically significance here, but clinically significant, I don't think we can, I don't know, say that the 3 from 1 to 5 is clinically significant. So we have to pay attention not only to the statistical significance part of the method and the results, but also the clinical significance. And conclude only significant results and do not talk about main questions. This was mentioned in one of the talks that Mark had a while ago, but still happening. And again, from 2004, and I've seen this something recently, that they have the main aim and then several, I don't know, secondary aims, and the main aim is not significant. 1 or 2 of the secondary aims are, and they just talk about of the secondary aims, but they don't mention anything about the main aim. Not only that it was like, they don't even mention that it was not significant. So I always tell people, you should stress, you should conclude things first present the first aim and then the secondary aims and talk about everything. Another pitfall, concluding no difference when results are not statistically significant, but finding no difference doesn't mean that there's not a difference. So it means that we haven't seen one, right? We haven't shown it to exist. And then also conclusions that overgeneralize. So for example, here, if we evaluate something in high school students and say that it applies to all females, and I've seen this in, well, still recently, that you measure it in a small population, and then it implies that it applies to the whole country and things like that. Now, describing bad based on bad graphs, and I have bad graphs in quotes because this is an example that I had with, let's say that you want to see a change on variable X. So you measure variable X before, I'm going to call this measurement 1, and after measurement 2. So I have this example where I have measurement 1, a box plot, and then measurement 2A, measurement here, the second box plot. And also I have this other example 2, where I have measurement 1, exactly the same as the other box plot. But now this measurement 2 is a little different from like 2B from 2A. But if you pay attention to each box plot separately, you can see that basing of that, you might be able to see, okay, the measurement 1 from measurement 2A didn't change a lot. And you can sort of have the same conclusion from measurement 1 to measurement 2B, like the measurements didn't change a lot. Now, if we were to do box plots of the difference of 1 minus 2A and 1 minus 2B, we will get something like this. So this is a box plot, or 1 minus 2a, 1 minus 2b. So you can see that this is very different to this other box plot. If we were to only see this, we wouldn't be able to conclude these things, right? And why is this happening? Because when we have measurement 1 and 2a, and this, for example, this point all the way down went all the way up, this point over here, and then this all the way high went all the way down. And in 2b, it didn't change a lot. So that's why we get these differences over here. So that's what I'm saying, bad graphs, because I've seen people that, present this as, okay, so we didn't see a lot of difference between measurement 1 and measurement 2, when in reality, things were very, very different, right? In each case. So that's why I think, well, if you want to present measurement 1, perfect, because you need where the baseline is, but then present it this way so that we know that there's a difference. Now, where am I right now? Let's see. Well, also wanted to present some examples of wrong terminology. Trend, this word I see a lot, but trend has to do with something that has an order, that you have several data points. And but people use trend for many, many things that don't have to do with this concept. Also, wrong terminology, parameter and estimates, for example, talking about risk when it should be rate. And yes, things like that. Now, saying that there was a reduction or increase when there is no pre-post. So if you're talking about treatment A and treatment B in different populations, we shouldn't be saying reduction or increase because there's no pre-post. And well, just to sum everything up, everything goes together. Research question, background, methodology, analysis, sample size, the graphs and tables, and interpretation and conclusions. And I want to finish with a quote from the ethical guidelines from the American Statistical Association from 1999 that says the use of statistics in medical diagnosis and biomedical research may affect whether individuals live or die, whether their health is protected or jeopardized, and whether medical science advances or gets sidetracked. Because society depends on sound statistical practice, all practitioners of statistics, whether the training and occupation, have social obligations to perform their work in a professional, competent, ethic manner. And that's it. So these are some of the references, and that's it for my talk. Are there any questions?
If you have questions, you can unmute yourself and ask, or you can type it into the chat. I have a question, Luz.
Yes.
If somebody is coming to a consultant at the beginning of their project, what types of information do you think they need to provide to the consultant to make a meeting very productive and go very smoothly?
Well, I think most of the time they already have an idea of what they want to do. Because I've also have people that come with like, I don't know much, so it's just a matter of checking what the research question is. But many of them already have the research question in their mind, maybe not completely defined, but have an idea. So it's more of what the research question is, what's your population under study, how you're going to measure it, things like that. I guess that in the background, right? Like, why do you want to measure it? What are you going to be using for measuring it? If you already have, again, some people might not have all that information, but if they already have it, then that's way better, right? So I guess as much information as possible, because sometimes it's when it's going back and forth, and when you have that, then sometimes research questions change because it has to do with, okay, maybe you wanted to measure this, but this is not available, or this is not doable, not feasible, right? So, but try to come with as much information as like what's happening in your mind, and what do you want to measure, what's clinically important, and then I guess that's what it's needed. But just a quick thing of, I want to calculate a sample size. This is my research question. This is not enough. It's more of why do you want to do it, where you want to measure it, et cetera, et cetera. Right? Many of the things that I mentioned in the talk.
Are there other questions?
No questions. And sorry, my background, like you can see me now, the things that the lights, since I have to move here in the room.
Yeah.
The
Yeah, the light went out here.
Yes.
Okay, we will conclude this seminar then, and we will post the video for people to look at later. And something to mention is that we are done with seminars for the rest of 2022, and we'll start up again in February of 2023.